this lesson, we're looking at direct variation. We'll go through and we'll define what direct proportion or direct variation is. We'll look at how we can use proportionality, and then we'll look at a few examples of how this would apply. So initially, we'll start by looking at a direct variation definition. So we all know what proportionality is. If two things are in proportion, then the ratio relating them is constant. So a really simple example of that is the circle. And this is a ratio that we all know. So if we consider two different size circles, then we know that there's a relationship between the radius and the circumference. So again, radius and circumference. So we know there is a relationship there, and we know it's a constant relationship. When this type of scenario exists, then we can make the statement that the circumference and the radius is directly proportional. In other words, that ratio relating them is a constant thing. So the circumference is proportional to the radius, and that means there's some constant variable there, so kr. Now in this case, we know what k is, because we all know our circumference rule. We know that circumference is 2 pi r. So k in this case would be 2 pi. That's that constant value that we can multiply the radius by and calculate the circumference for any circle. Now a circle is an even better example because it doesn't just have one proportional relationship, it has two. And the second proportional relationship will be that the area is proportional to the radius squared. So the relationship that we're finding between different variables doesn't need to just be a simple relationship. We can look at different relationships like square and square roots and cubes and so on. If we can define that relationship, so in this case, our relationship is that the area is directly proportional to the square of the radius, then we can use this directly proportional relationship and say that the area is kr squared. In this case, again, we can define what k is, and we could do that by calculating or knowing what some areas are and knowing some radiuses. But if we did that, we know that that relationship is pi. So we know that the area would be pi r squared, just like we know the circumference of the circle would be 2 pi r. Right. So there's a couple of properties that we want to write down for directly proportional relationships. Now the first property is that a directly proportional relationship will pass through the origin, or 0, 0. And the second property will be that if y is proportional to some function, let's say x to the power of n, then the graph of y versus x to the power of n will be a straight line passing through the origin. Okay, so let me look at this in a little bit more depth. So consider the function y is equal to 2x squared. If I was to set up a table for this, x versus y, then we've got a good idea of what this will look like, right? So if x is equal to 0, 1, 2, 3, and 4, then the values we get, we sub in 0 and we get 0. We sub in 1 and we get 2. We sub in 2 and we get 8. We sub in 3 and we get 18. And we sub in 4 and we get 32. Now if we sketch this as x versus y, then when we plot our point 0, 0, 1, 2, 2, 8, 3, 18, and so on, then we get that classic shape, which is a reflection on the type of function that we're looking at in this case, an x squared, a parabola. If we do up a similar table, but now we look at x squared versus y from this same scenario, and then x squared is 0. So we can see it fits one of those conditions. It's going to pass through 0, 0. X squared is 1, so we've got 1, 2. We've got 4, 8, because 2 squared is 4. 3 squared is 9. And 4 squared is 16. Now already, I think you can see that pattern. You can see that y is always double x squared. If we plot out those points, then 0, 0, 1, 2, 4, 8, and so on, then what we get is a straight line that passes through the origin. The gradient of that line is determined by the k value, and that k value we call the constant of variation, or the constant of proportionality. Basically, now we end up with an understanding that if y is proportional to x, if y varies directly with x, we can write it as y is proportional to x, and therefore y is equal to kx. Now, at the same time, for any other power relationship, we can say that if y is proportional to x to the power of n, then we can write that as y is proportional to x to the power of n, and then we can say that y is equal to some constant of proportionality multiplied by x to the power of n. Okay, so that's what we're looking at, and we'll go through a couple of examples now. Okay, so in this example, we're looking at a scenario where in each case, use of a table of values to determine the constant of variation k, and hence complete the table. So really, in this first one, we've got a simple relationship, y is proportional to x squared, which means we've got y is equal to kx squared. We want to use at least one piece of information to be able to determine that relationship, and then we can use that relationship to determine the other values. So we know that when x is equal to 2, y is equal to 12. So we have y, which is 12, is equal to k times x squared, which is 2 squared. So 12 is equal to 4k, and therefore k is equal to 3. Now that we know our constant of variation, we can test it. So now we know our constant of variation, we can say that y is equal to 3x squared. So now we can work out the remaining values. When x is equal to 4, then y is equal to 3 times 4 squared. So that gives us 48. We can test it. X is equal to 6, then y is equal to 3 times 6 squared. 3 times 36 is 108. That's good. And then the third one, we don't know x, but we know that y is 192. So we've got 192 is equal to 3x squared. So if we divide by 3, then we get 64. So we've got 64 is equal to x squared, square root of x, and we get x is equal to plus or minus 8. Obviously, we're just looking at a scenario where we're increasing these values, so we're going to use positive 8 there. So we can say this is 48 and this is 8. So we complete our pattern. The second example, we've got y is proportional to the square root of x, and so that means we've got y is equal to k square root x. When x is equal to 4, then y is equal to 1. So we've got 1 is equal to k multiplied by square root of 4. 1 is equal to 2k, and therefore k is equal to 0.5 or 1/2. So that gives me the relationship y is 1/2 of the square root of x. Now we can substitute in values here. When x is equal to 2, then we get y is equal to 1/2 square root of 2. So we'll just leave it as that, 1/2 square root of 2. And we also are looking at then when y is equal to 1.414, and I'll need my calculator for this one. We've got 1.414 is equal to 1/2 square root of x. We want to divide by 1/2, which is multiplied by 2. So that gives me 2.828 is equal to square root of x. And x will be 2.828 squared, which works out to be approximately 8. So there's the rest of our values there. Hopefully you can see how simple that is. If you're given that proportionality relationship, you should be able to work out that k value, and using that k value, you can determine any other value you wish. To add a little bit of complexity here, we can give real-world scenarios. This is more likely going to pop up with these types of questions. In an electrical wire, the resistance varies directly as the length of the wire. So they've given us a relationship that resistance R is proportional to the length. So R is equal to KL. Now they give us a piece of information here. If a 6 meter wire, so length is equal to 6, has a resistance of 5 ohms, so R is equal to 5. What is the resistance of a 4.5 meter wire? Okay, so we can use this first piece of information to find that constant of proportionality. We know that R is equal to KL, so 5 is equal to K multiplied by 6, and that means that K is equal to 5 on 6. Now with the second piece of information, we know that R is equal to 5 on 6L, so R will be 5 on 6 multiplied by a length of 4.5, and that gives us a resistance of 3.75 ohms. Okay, so it's as simple as that. Basically, you'll be given a relationship. Once you define that relationship, you'll be able to work out your constant of proportionality. Once you know your constant of proportionality, you can use that to solve for any other unknowns. Okay, so our last example is a complex, familiar one. The volume of a sphere varies directly as the cube of its radius. So that cube of its radius is really important. We're saying that the volume is proportional to the radius cubed. That means we've got volume is equal to KR cubed. By what percentage will the volume increase if the radius is doubled? Now, this is the type of scenario, they're not giving us information to determine an exact value, but we're looking at a percentage change. So percentage change is basically going to be the change over the original times by 100%. And in order to find the change, we need to work out what the original was and what the new value. So let's say an easy way to do this is determine or make up an original value. So we might say that originally R is equal to 1. And if R is equal to 1, then V is equal to K times 1 cubed, which is just K. Now, in this case, we're doubling. So if we're doubling, R is equal to 2. And therefore, V is equal to K times 2 cubed, which means that we're left with 8K. Once we've got these two, we're able to look at it as a percentage change. So if we go back to our percentage change, our change will be the new value take away the original. So we've got 8K take away K over the original value, which is K, times by 100%. And that means we've got 7K on K times 100%. K's cancel. And that means our percentage change is 7%. So if we doubled the radius, then the volume will increase by 700%. Now, when we look at the second scenario, we're going to increase by 20%. So we'll do the same thing. Initially, I'll let R equal 5. And the reason for that is that 20% of 5 is 1. So that makes it nice and easy. That means that the initial will be R is 5, and the next one will be R is 6. So increase by 20%, multiply by 1.2, we get 6. So this gives me a volume of K times 5 cubed, which is 125K. A volume of K times 6 cubed, which is 216K. And therefore my percentage change will be the change, which is 216K, subtract 125K, over the original, which is 125K times 100%. That gives us 91K over 125K times 100%. K's cancel, and we're left with an increase of 72.8%. So increase of... So I think that's the easiest way to deal with those problems. There are other ways, more algebraic approaches, but I think that's the simplest way to interpret it. So if we go back up, remember the whole idea is if we've got a proportional relationship, then they differ by a common constant of proportionality. All right? Thank you for listening.